Hello my dear PU1 students, welcome back to Diksha Karnataka YouTube channel. And if you are someone who is struggling to solve numerical problems, if you are struggling to remember some formulas, in this lecture I am going to share all the important formulas, important concepts that you need to remember to solve numericals, and I am going to solve 12 selected numericals for your entire PU1 final exam. If you watch this video till the end, all your problems related to numerical questions will be solved. Only 12 numericals. Also, I will suggest few chapters from where you should practice numericals if you have time to practice more. Otherwise, if your exam is tomorrow or day after tomorrow, if you don't have too much time to revise, then definitely you have to check this entire video till the end. Okay, don't skip it. If you want, you can speed this video up to as your speed of liking, but you cannot skip this video and you cannot appear in your PU1 exam if you are someone who is struggling to solve numerical questions. So all the problems related to numerical questions will be answered in this video. So let's start with what is the weightage of numerical questions. So how many questions we can expect? We can expect 4 numerical questions in total, and out of that you have to answer 2 of the questions, and that is 10 marks is particularly reserved only for numerical. So if you want to score those 10 marks, which is relatively easier, you don't have to remember too much of stuffs, only few formulas, few equations, and your brain which is already there. If you apply your brain, definitely you can score this 10 marks. Also, remember that there are part marking, so even if your final answer does not match, if your approach is correct, definitely you are going to get some part marking as well. Right, now what are all the chapters that I recommend to practice numericals from? So motion in a straight line, easy chapter. Motion in a plane, where we have vectors and projectile motions, 2 important concepts from this chapter. This is also very important. Next, Newton's laws of motion. Simple and easy. There are tricky questions, but for your PU1 exam, if the question is set according to the board standard, definitely you can answer questions from this chapter as well. Now gravitation is another important chapter. Again, if the question is coming from board standard, definitely you can answer. Now why I am recommending 4 chapters? Basically, you cannot predict from where the questions will come. There may be some difficult questions coming from the system of particles chapter, or maybe some difficult questions from thermodynamics, difficult questions from wave motion, right? So those chapters, there are a lot of tricky questions and lot of questions you need to practice to master those chapters. Okay, I can recommend thermodynamics. If you are good in thermodynamics, that is another chapter from where you can expect another numerical questions possibly. But otherwise, if you are not good in thermodynamics, then definitely these are the 4 chapters you have to look for. Okay, so thermodynamics, only if you are good at that chapter, you have to practice the numerical questions from the exercise of NCERT book, and if you are not so good, then definitely these are the 4 chapters I am recommending, and I am going to solve 3 questions from each of the chapters. Also, there is a bonus. I have not solved 2 numericals from your model question papers, question number 44 and 45. A lot of you have requested me to solve those 2 questions, so I will be solving those 2 questions at the end of this video as well. So you have to check that out as well. If you are expecting that, sir, my teacher said those questions will come in the exam, definitely you have to check those 2 solution as well. I gave you the hint, but many students struggle to solve from the hint I have given, so I am going to solve it manually at the end of the lecture today. So let's see. The first question is from the motion in a straight line chapter. Okay, and you will realize, even though the chapter may appear difficult, not all the questions are difficult. You have to apply slight knowledge, slight formulas. Obviously, there are 3 equations of motion, so you have to apply those equations of motion. Based on that, you have to solve the numericals, right? So let us first give you the 3 most important equations of motion. First is V. Let me change the color. V equals to EU plus AT. Okay, now this plus sign indicates that body is accelerating. If it is decelerating, or sometimes we call it retarding, okay, the motion is decelerating or retardation, then in that case the sign will be negative. Okay, otherwise in general the sign is positive if we know this is the body is accelerating, right? So v is equal to u plus at is the first equation. Obviously v is the final speed, u is initial speed, a is acceleration, t is the time. Next is s equals to ut plus half at square. Okay, this is the second equation. S is the displacement of the object after some time t. Initial speed is u, acceleration is a. Based on the problem and question, a can be the value of gravitational acceleration. We will see in our first problem as well. So instead of using a, we will use g. Okay, other than that, this is the basic formula. Next is obviously v square equals to u square plus 2a. S. These are the three equations of motion. Now based on the data given to us, okay, so as you can see in the third equation there is no time involved, right? In the first equation no displacement involved, right? In the second equation no final speed is involved. So based on whatever information is given to us, we will use one of the three equations. Now these three equations are convertible. You can convert from one to another, but to save time, to save our efforts, we will use the equation which is more useful given the problem. So first we will see the problem and we will understand why we are choosing certain equation over another. So a body let fall from the top of a tower covers 45 meter in the last second of its fall. Find the height of the tower. So you have some height of the tower, okay, and say the height of the tower is capital H. Okay, now when you allow it to fall, it will fall throughout the distance, right? And the last second, that is the just before touching the ground, last second it travels a distance, say 45 meters. That is the given equation, given part. Now we have to calculate the entire height h. That is the question. Now time is not given. Initial speed is 0 because it is let it fall. We have allowed it to fall from the top of the building, so initial speed is 0. So what are all the given data? Initial speed is 0. Okay, time is not given. Obviously it is accelerating with gravitational acceleration, that is g, that is 10 meter per second square, and last second fall, in last 1 second it falls a distance 45 meter. That is also given. Now how to solve this question where time is not given? So first part is to calculate the time. Okay, we cannot start with velocity, final velocity, we cannot do that. So we have to first find the time in this case and then apply the time to calculate the height. So how do we know? So first we will say that if the body was allowed to fall, say it falls for a time t second. To reach the ground. So this is the first part that we have to assume. Trust me, it is not so difficult once you analyze and answer this question. So t second is required to reach from starting to end. Okay, so t second is required for it to reach from starting to end. Now what is that height? So height basically is given by h. We have assumed that maximum height is h. H is equal to ut plus half gt square. Now u is 0 given, okay, so h will be equals to half gt square, right? So this is the first equation. You can name it, okay, so the teacher can understand that you have understood this question. Right, now what we will do, we know that in t minus 1 second, whatever height it has traveled, and the difference from h is 45 meter. So in t minus 1 second, the height is h dash, say. So t minus 1 second means when it is reaching here, right? So this is the t minus 1 second. So in t minus 1 second, how much height it will fall? Same equation, t minus 1 whole square. Same equation, only thing is instead of t we will put t minus 1. But what we have done, we know that in the given question it is given that h minus h dash is 45 meter. That is given in the question. Okay, so the difference in the height of total distance traveled and the distance traveled just 1 second before it hits the ground, that height is given 45 meter. Now we will use these values here. So half g is common. If you see, half g is here as well, half g is here as well. So it will be t square minus t minus 1 whole square. That is equals to 45. Now we have to simplify this part. How to do that? And this is given, right? If you put the value of g here, you will get half into 10. That is 5. Right, now what is the value of t square? T square will be t square minus, so let's see, let's divide it, t square minus 2t plus 1, right? So this is the value equals to 45. Now 45 and 5 can be cancelled, so you will get 9 on the right hand side, right? So 9 on the right hand side. Now you have to break this bracket, so t square minus t square plus 2t minus 1 equals to 9, right? So we have just multiplied negative sign in this bracket and we have break this bracket, so t square cancels, so we get 2t minus 1 equals to 9, or 2t equals to 10, or t equals to 5 seconds. So we have calculated the total time of fall. So why we have applied this equation in this case? Because no information about v was given. Okay, only thing that was given to us is about some distance traveled at the last second. So that is why we chose the second equation is the most effective. In fact, when you solve the questions, the second equation will come more than often than not. Okay, yes, sometimes you will use the first equation, sometimes you will the third equation as well, but second equation is the most common. Okay, and in motion in a straight line problem, okay, you will be solving using this equation the most. Okay, and in other question, for example in the laws of motion chapter, you might use the first equation more than the third equation. Right, now what we have to do, you have to use this t is equal to 5 second in equation 1 to calculate the height. So height is basically half, g is given as 10 and t we have calculated 5, so it will be 5 square, right? So it will be 5 cancels, so 5 into 25, that is 125 meters. Okay, so let's see the answer. So it is 125 meter is the answer to this question, and we have arrived at that point. Okay, question may appear difficult, but you can solve it without much difficulty if you know what equations you have to use and how you can solve this kind of questions. Now second question, from the velocity time graph given below, calculate the total distance traveled. So this is a triangle. Okay, first is this, second is this, and this is the height. Now how can you calculate the total distance traveled from the velocity time graph? So in the velocity time graph, total distance traveled is nothing but the area under the graph, right? So area under the graph. Now you might think, sir, I have to calculate two triangles, this one triangle and another triangle. No, there is only one triangle. This is also a triangle, right? And the formula for calculating the area of a triangle is same. Right, what is the formula for? We know that you have to write it here clearly, that area under the VT graph represents the total displacement, right? Or total distance traveled, whatever you want to write. Now so basically what you have to do, calculate this area. So displacement or total distance traveled is basically area of triangle. Let's name it. You have to draw this triangle on your notebook as well, ABC. So area of the triangle ABC. Okay, you have to draw this triangle on your answer sheet. So area of the triangle ABC. Now what is the area? Half base into height. Half base into height. So what is base? Base is, it is 0 point, it is 10 seconds. So base is basically 10. And what is the height? Height is given here 12. So you have to do it 12. So cancel it. 6, it will be 60 meters. Be careful about the unit. Simple question. Okay, only thing that you have to know is the area under the graph of VT graph represents the total distance traveled. Okay, now let me know in the comment below what is the area for a acceleration time graph. Is there any meaning of area under the acceleration time graph, or what is the area of the distance time graph? What are the meanings? Let me know in the comment below. So answer is 60 meters. Next question, let's move on. A ball thrown vertically, a ball is thrown vertically upwards, reaches the balcony of a house 100 meter high. So again you are suppose this is a balcony at a distance 100 meter from the ground. Okay, you throw up a ball from this, it reaches this balcony. Okay, it reaches this balcony and the height is given 100 meter. Now at the same time another ball B is dropped. This is ball A, this is ball B. Okay, B is dropped from the rest of the balcony, from the balcony of the house. So it is just dropped, okay, without any giving speed, right? When and where will the two balls pass each other? So suppose this ball reaches at this point, this ball reaches at this point. Okay, what is this point that you have to find, and what time after it started? So suppose this distance, say x, so you have to find the x and also you have to find the time t. Now if you see, the speed of the ball which is thrown from the ground is not given. Definitely it was thrown with a speed, because then only it is going up, but what is given is it reaches a height of 100 meter. That is given. So that means the ball is coming to a stop when it is reaching at the top of this balcony, right? So that was given. Now you can use one-dimensional equation of motion or motion in a straight line equations to find its speed. Okay, you have to use two equations. You can do that if you want, you are fine. But since we have completed the entire chapter, all the chapters we have completed, we know that from the conservation of energy, whatever is the kinetic energy of the ball at the ground, when it is reaches the top, that is it is coming to a stop, that entire energy is converted into potential energy. That fact we will use to solve this question. Otherwise you can use one-dimensional equation, 3 equations that I have wrote. You can use those equations to solve this problem as well, but that will be slightly longer and slightly complicated than whatever method I am teaching you to solve such kind of questions. This is a standard questions taken from your PU1 model question paper. Model question paper means the question bank, sorry, not model question paper, question bank provided by the board. Okay, you can download it from the PU board website, question bank. There are 2 question banks, PU1 and PU2, 24-25. You can download it from there. Anyway, so basically that means we can apply the conservation of law principle. When you are solving this question, maybe when the first time you came to PU1, started solving such questions, you might find, oh, this is very difficult, I will skip it. But now after completing the gravitation chapter, work energy chapter, we know that the whatever kinetic energy of the ball at the beginning, the same energy will be converted into potential energy, and the energy will be, we can equate those two energies, right? So suppose the mass of the ball is m, m, the initial speed say u, final height is 100 meter, and gravitational acceleration is given 10 meter per second square. Even if it is not given, you can assume 10 meter per second square unless and until they have specified take 9.8, you can assume the value of g to be 10. Okay, answers will be slightly different than if you assume 9.8, otherwise always assume 10. Okay, and you are allowed to use simple non-programmable calculator in your final exam, so you can use the calculator to calculate the value as well. Right, now let's see what is the how to solve it. First we will compare the energy. So half mv square, you have to mention, let us assume the mass of the ball is m, initial speed is u, then from the conservation of energy we can write half mv square equals to mgh. Now we don't know m, obviously the conservation of energy principle, that is the beauty of this, that m basically cancels from both sides. So sorry, this is u square, right? So u is basically equals to square root of 2gh. Right, so u square is 2gh, so u is square root of 2gh. Okay, or 2 into g is 10, h is 100 meters. Right, so what will be the value? So it will be 100 square root is 10, 2 into 10 is 20, 20 means 4 is to 5, so 4 square root is 2 and 5 is still left inside the square root, so it will be 20 root 5 meter per second is the initial speed. Okay, so 20 root 5 is the initial speed of the ball that is thrown from the down. Now the ball which is dropped from the top, it is starting from initial speed of 0, so its initial speed is 0. Right, now after traveling say x height, it is meeting the ball B. So ball A travels a distance say x height, and then at the height x it is meeting the ball B. So what is the displacement of ball A? Displacement is x. What is the initial speed? Initial speed is obviously u, this u. Okay, u. Say time taken is t, so time taken is t, and as it is going up, there is a deceleration acting on this ball, downward direction, right? So deceleration, what is the value of that deceleration? The value of the deceleration is g and gt square. S equals to ut plus half at square. In this case, because ball is going upward, the deceleration is acting downward, so ut minus half gt square. That is the displacement of the ball A. Now the same time the ball B is traveling distance this much. What is this distance? So total distance is 100, this ball traveled x, so this must be 100 minus x. This distance traveled must be 100 minus x. Now this ball is dropped from the initial speed 0, dropped from the rest, so 100 minus x can be written as 0 plus half gt square. Same time, obviously this ball will also take the same time, right? The same time the ball falls, this ball rises, so they are dropped at the same time, so they are meeting at the same time, so time difference should be 0, so they are both will travel the same distance, they travel the same time. Right, now what we have to do, you have to add these two. So if you add these two, what you will see that 100 minus x plus x, so it will become only 100. Okay, x and x will cancel. I'm not cancelling it because I need this equation later on. Okay, so this is 100 equals to, if you see this is minus, this is plus, so they will cancel. So again you just getting ut. Right, so what is t here? So t is basically 100 divided by u. Very simple, you just have to follow the methods, okay, and use value. We know 20 root 5, so just divide it. So 5 20 is 100, so 5 divided by root 5, that is equals to root 5 seconds. So root 5 seconds is the time after which the balls met. Now you have to calculate the x value as well. Okay, when and where. So where means the x value you have to calculate as well. So x equals to u is what? 20 root 5 and time is root 5 minus half, g is given 10, and t square means root 5 whole square. Okay, so you can say that 20 into root 5 is 5 minus half you can cancel it here, so it will be 5 into square root of 5 whole square. Square root of 5 whole square is nothing but 5, right? So you will get 100 minus 25, that is 75 meters from the balcony, from the ground. Yes, from where you are measuring this height is also important. So here we are measuring this x is from the ground. So at a height of, you can say at a height of 75 meter, or you can say 75 meter from the ground, whatever your desire is. So time t equals to root 5 second at a height x equals to 75 meter. Okay, clear? If you solve the same problem by solving this 100 minus x, that is also correct. Okay, you have to mention that 25 meter below the balcony. If you are mentioning this distance, that will be 25 meters. So that is also correct, but you have to mention 25 meters below the balcony. You have to mention the reference point as well. Okay, you can use the second equation as well to calculate the distance, but here you have to mention 25 centimeter below the balcony, and then in that case you have to assume this is x, this is 100 minus x. Okay, clear? Everything clear? Let's move on to the next chapter, motion in a plane. So motion in a plane, we will deal about with vectors as well as the projectile motion. Both are very, very important. The resultant of two forces acting at an angle of 120 degrees is at right angle to the smaller force. If the greater force is 8 Newton, find the smaller force and the resultant. So in this case you have to draw the diagram. First we have, suppose I generally like to draw triangle addition of vectors. If you want, you can draw the rectangular addition of vectors as well, whatever you are comfortable with. So this is the first vector, say A. Okay, the first vector A. Suppose this vector actually up to this point, I don't want to extend it. So this is, say, A, and say this is B. Okay, the angle between the vector is 120 degree. Okay, this is the this is how you draw in case of triangle addition. Okay, the angle is basically this one, not this one. Okay, now so this is A, say, this is B, say, and it makes an angle 90 degrees with the smaller vector. Okay, it makes an angle 90 degree with the smaller vector. What you have to do, you have to find the individual vectors. Greater force is given 8 Newton. Okay, what is the smaller force? Now we know that whenever you are calculating the angle, okay, the formula for resultant angle tan phi is given by A sin theta divided by B plus A cos theta. Now how to remember it? How to remember this formula? So to remember this formula, first of all you have to remember that whatever the base we have considered, that base sin theta, theta is this is the theta. Okay, and also remember that if you ignore the B, AA will cancel and you should get a tan theta. Okay, AA should cancel, you will get a tan theta. So the other one will be added extra. Okay, this is how you can remember this formula. This formula, when I was a student at your age, it was very difficult for me. I could remember the resultant formula, but angle formula was very difficult for me to remember. So I started remembering like this. Okay, so tan theta on our left hand side, tan theta should be on our right hand side as well. How to do that? So the both coefficients should cancel, and this B should be extra addition. Now what is the value of phi? Phi is the this one is phi. right? So phi value is given not 120. Resultant angle is given as 90 degrees, right? Right angle means 90 degrees. So tan 90, what is the value of tan 90? Tan 90 is basically infinite, right? Tan 90 is infinite. Now how can a number be infinite? If I want to solve this is very tricky, right? So if it was 45 degrees, tan 45 was 1, we could have solved it, but trust me, this is easier than that. Okay, so why so? Because a sin theta by b plus a cos theta, right? Now if a number gives you an infinite value, that means, suppose if I say x by y equals to infinite, then that means this denominator must be equals to 0. The denominator has to be 0 to get this equation true. So only way to get this is basically b plus a cos theta must be equals to 0. Okay, so let's solve the value. So b equals to minus a cos 120 degree. Now what is the value of cos 120 degree? Cos 120 degree can be written as cos 90 plus 30. Now if you see all sine, tan, cos, so second quadrant cross will be negative, and cos 90 plus 30 can be written as sine 30, so it will be minus sine 30 degree. Okay, so cos 120 degree is basically minus sine 30 degree, so you can say a sine 30 degrees, right? So what is the value of sine 30 degrees? Sine 30 degree is basically half. Now we have assumed this is the greater force, right? The angle we have considered is B, so greater force is A is 8 Newton, so you just put that value over here. So 8 into half, that is equals to 4 Newton. So we found that A is 8 Newton and B is 4 Newton. Now we have to calculate the smaller force and resultant. So smaller force we have calculated, now we have to find the resultant. What is the formula for resultant? It is another easy formula, a square plus b square plus 2ab cos theta, right? This is the formula for resultant. It is similar to a plus b whole square, only thing there is a cos theta which is added to this 2ab term, right? Now we have to put the values. A square is 8 square, b square is 4 square plus 2 into 8 into b is 4. Now we know the cos theta value. Cos theta is basically minus sine 30, that is minus half. Okay, cos 120 degrees basically minus half. Now in this case we had a negative sign, so that negative was cancelled, but in this case there is no negative sign, so it will not be cancelled. Okay, so 8 square is 64, 4 square is 16. This minus sign will come here. Okay, you can cancel these 2's. Okay, and 4 8's are 32. So you will get 32 plus 16, that is 48. Okay, 64 minus 32 is 32 plus 16 is 48. So this value will be very close to 7 Newton. Okay, very close. You can use your calculator to find the square root, but 48 is close to 49, so I know for a fact it will be very close to 7, right? Let's see the exact answer using a calculator. So you will F is equal to 4 Newton, we know already, and R is 6.93 Newton. Okay, even if you finish it nearly 7 Newton, you should get full marks. Don't worry about it. Okay, because there is a tolerance given to you, 10% tolerance is given, so as long as your answer is between 6.5 and 7.5, you should get the full marks, but don't deviate too much from the actual answer, so it will be 6.93. If you have a calculator, you can calculate it now. Next question, a football player kicks a ball at an angle of 30 degrees to the horizontal with an initial speed of 20 meter per second. Calculate A, the maximum height, and B, the horizontal range reached by the ball. So this is a typical projectile motion problem. This is the projectile motion. The angle of projection is given 30 degrees. Okay, so you have to calculate the height, you have to calculate the range, right? So you have to calculate the height, you have to calculate the range. We have solved 2 more numericals from the last 2 chapters. In your model question paper, you have to check those 2 numerical questions as well, right? Now let's see what is the range formulas for range and height. You have to remember the formulas for height. Height is u square sine square theta by 2g. This is the formula for height. Okay, so first we will calculate the maximum height. So let's put the values one by one. U is given here, initial speed of 20 meters per second. So u is given, so you have to write the given quantities while solving this, and diagram is compulsory. So u is 20 square sine theta, square theta, so sine square theta means sine 30 whole square, right? Sine square and sine theta whole square is same. 2g, g is taken to be 10, right? Now even if they don't mention it, you can take it to be 10, okay, and there will be no deduction in marks for you considering the value of g to be 10, unless and until they have given some values here, 9.8 or 4.9, which is multiplier of 9.8, and you can cancel them easily. Then 9.8 assuming is perfect. And especially in case of competitive exams, they will mention the value of g, but in the board exams, or sorry, not board exam, in your PU1 final exam, they generally skip the value of g. Teachers forget to mention it, or sometimes they deliberately remove g to check it. If you know that, you have to assume g is in 10 or 9.8 based on the question, right? So that's why it varies from teachers to teachers, it varies from college to college. Okay, so it will be 20. So 20 into 1 by 4, so that is 5 meter. Very, very important to use the unit 5 meter. So height, maximum height is 5 meter. Now what is the formula for range? Range is again given by u square. U will always be square. Okay, in one case sine square theta will be there, and there will be a division of 2g. In the formula for range, sine will be 2 theta, and because this 2 is taken by sine, both 2's are taken by sine, so there will be only left with one single g. This is how you can remember, okay, that when there is a sine 2 theta, there will be no g in the denominator. If there is a sine square in the above, there will be a 2 in the denominator. That's how you can remember the values. You have to, these 2 are the essential, most essential formula for solving numerical questions. Okay, only 2 equations, and there is a time of flight as well. We have discussed about time of flight in our model question paper. If you have not checked that video, go and check that video. So it is u square is 20 whole square into sine 2 theta. Sine 2 theta means, what is the theta? Theta was 30 degree. So we will use our shortcut and we will directly use sine 60 degree. Instead of breaking down sine 2 theta into 2 sine theta into cos theta, we will use that fact that sine 2 theta means 2 into 30 degrees. 2 into 30 degrees 60 degrees. So we will directly use that, right? And g we will use as usual is 10. So that is 400. 20 square is 400. Sine 60 degree is basically root 3 by 2, and we have another 10 in the division. That 10 will cancel. So 40 means 20. Okay, these 2 and 40 will cancel. So 20 root 3. You can use your calculator to calculate the exact value. I know for a fact root 3 is almost 1.7. okay, that will be 34. The answer will be 34, slightly more than 34, but that is also acceptable answer. So 34 meter. Let's see the answer. So answer is 5 meter height, range is 34.64. okay, that is fine. So as long as your answer is within the range, you will get full marks. Okay. Next, another question, again it is from the projectile motion. The ceiling of a long hall is 25 meter high. What is the maximum horizontal distance that a ball thrown with the speed of 40 meter per second can go without hitting the ceiling of the hall? So what is the question? So we have a hall, ceiling hall, which is given at a height of 25 meter. This is a hall, okay, very long hall, and if you hit the ball with the initial speed of 40 meter per second, how long you can hit it? So how long you require that it should not hit the bottom of the ceiling. That means the maximum height should be given by the maximum height is 25 meter, that is given. Okay, the initial speed is given 40 meter per second. The angle is not given. Okay, the range you have to calculate. Maximum distance means obviously the range you have to calculate, right? Theta is not given, h is given in this case. So how to solve it? We know the formula for h is basically u square sine square theta by 2g. Okay, again we will use g is equal to 10 in this case. If you use 9.8, you have to use the calculators from the beginning, but that answer will not super different from 9.8 if you use, but that will be a lot easier for us to calculate. So h is 25 centimeter, u is 40 whole square, sine square, theta is not given, it is 20. So let's solve. Sine square theta equals to 25 into 20 divided by 40 square. Okay, so this comes down, this goes up, so, cross multiplication simple, right? So 25 into 20 divided by there is a 2 also, sorry, 2 into 10 only 20, right? So 40 into 40. Okay, so this 0 cancels, this becomes 2, so it will be, so sine square theta is basically 25 by 80. Okay, sine square theta is 25 by 80. So sine theta 5 by square root of 80, 80 means 4 into 20, that is 5, another 4, so it will be 4 root 5. Okay, you can leave it here, you can simplify it, root 5 by 4. Okay, but what this is sine theta, we have to calculate the cos theta as well. How to do that? So or you can, if you can calculate sine inverse from your calculator, which is not allowed I think in your PU board exam. So if you are using scientific calculators, definitely you can find theta, but since it is not allowed, what we will do, we will find cos square theta from this sine square theta. How to do that? Cos square theta is 1 minus sine square theta, that is 1 minus, this is very handy technique if you want to appear for any competitive exam in future, right? This kind of tricks are very, very handy. So 80 minus 25, 80 minus 25 means 55 by 80. Okay, so it will be 5 11s 55, 5 16s 80. Okay, so what is cos theta then? So cos theta we have calculated, cos theta is square root of 11 divided by 4. Now why we did that? Because we know that the range formula, the formula for range is basically given by u square sine 2 theta divided by g. Now sine 2 theta is basically, so 40 square into 2 sine theta into cos theta divided by 10. So we know for the fact that there is a sine 2 theta is coming, that means we have to use 2 sine theta and cos theta, right? So if you use the value, you will get 40 square is 40 into 40 into, there is a 2 over here, divided by 10, right? So one of the zeros cancelled, so you get, and into sine theta into cos theta. So what is sine theta? Sine theta is root 5 by 4 and cos theta is root 11 by 4. Okay, so let's cancel. This 4 will cancel with this 4, this 4 will cancel with this as 10, right? So what you will get? You will get 2 into 10 is 20 root 55 meters. Okay, so 20 into root 55 meters. You can leave the answer over here, or if you can use the calculator to calculate the value, which will be not exactly 150.5. By the way, this answer was calculated by assuming G to be 9.8, but that will complicate the answer a lot. You will get this answer very close to 149 meter. Okay, which is correct. Don't worry about the answer given in the standard book, but if you solve it, if you get the answer very close to 149, that is also acceptable answer. Okay, so these are the two different types of projectile motion. One case theta is given, easy formula, just put on the formula and solve it. In the second case, we are using the same sort of formulas, but in this case value of theta is not given. So it is given height, from there we have to calculate the sine theta. Now the problem is given, the data is not super good. If it was good data, then you could have got the value of theta directly, but if you see that theta is not given, you have to bypass the theta calculation, and you can directly use this method to solve R. Okay, if you can find the theta from this equation, then this part is not required. You just find the theta, put the theta over here, double it, find it, that is okay. But in case you are not allowed to find the theta directly, then you have to do this method. You should know all the possible methods to solve a question. Now, next question. A body of mass 8 kg is suspended by a rope of length 2.5 meter from the ceiling. A force of 60 Newton is applied on the body in the horizontal direction. Find the angle that the rope makes with the vertical in equilibrium. This is a laws of motion question, okay, equilibrium question, and obviously this question is taken from your last year's model question paper. Okay, last year's model question paper. So you have a rope of 2.5 meter, a body of mass 8 kg is suspended, and you applied a 60 Newton horizontal force on that. So it is definitely resting at some angle. You have to calculate this angle theta. Now this, be careful to solve this question. This data is not required. This value is unnecessary. You can solve it even this 2.5 meter length is not given. Why so? So you have to consider there is a tension acting on this rope. Okay, whenever there is a force acting on a rope, there is always something called a tension. Okay, tension is not only on your mind about the exam, tension is always there in the rope as well. Okay, now this tension, all the forces has to be balanced in equilibrium condition, right? What are all the other forces acting on this? The other force that is acting, always acting, that is the weight of the body, that is mg. Okay, so weight of the body is mg. Now what you have to do, you have to apply resolution of vectors from the plane chapter, motion in the plane chapter. That is, if you consider this one, okay, these two are parallel lines, so they are alternate angles. So if this angle is theta, then this angle will also be theta, right? So basically what we are doing, we are saying if this angle is theta, this angle will also be theta. So whenever you see a z, you will realize that these two angles are alternate angles, they are equal, right? So this is how you understand. So z is a very important figure in resolution of vector kind of problems. So you can see there is a z here, okay, even though the z is slightly tilted, but you can see there is a z here. So this angle theta means this angle is theta. So we have to divide this tension into two components. One component along this direction, another component is along this direction. Now what these two components will do, you have to remember that all the forces are in equilibrium, means all forces in the horizontal direction and in vertical direction should be zero. That means they should balance each other. Now if this angle is theta, then this component is called adjacent component. Adjacent component is always cos theta component, no matter what. If you remember this, if you remember this small little concept, it will help you to solve all difficult questions, in fact in your second PU as well, in fact in your competitive examination as well. Okay, so whenever you are saying adjacent component will always be cos theta component, and the perpendicular component will always be sin theta component. Okay, it can be proven geometrically, but the proof is not important. What important is you remember it. Okay, if this angle is theta, as soon as you see the angle theta, this component is cos theta, done. Other component is sin theta. Now so what are all the forces in the horizontal direction? 60 Newton in this direction, and a t sin theta component in the opposite direction. So from the equilibrium along the horizontal direction, now you have to mention that let the tension of the rope is T. We have to mention that. Okay, so T sin theta, and diagram is compulsory to solve this question, because without drawing the diagram you cannot answer this, which one is what. So definitely diagram is compulsory. So T sin theta is equals to 60, and for vertical direction, okay, T cos theta equals to mg, that is m is given 8 kg, g we will always take 10, so it will be 80. Okay, so it will be 80. Now what we will do, easy. This is 1, this is 2. We are trying to find theta, so we do not know t, so we have to eliminate t. How to do that? To eliminate, we have to divide sin theta, t sin theta by t cos theta. Right? If we divide them, we can solve it. That is 60 by 80 will be 3 by 4. Okay, so t cancels, so tan theta equals to 3 by 4. Now you can leave the answer over here, that theta is equals to tan inverse 3 by 4. Now those who have solved a few questions in the competitive exam, those who are preparing for competitive exam, they know that 3 by 4 is a special angle, and tan inverse 3 by 4 is basically 37 degrees. Okay, tan inverse 3 by 4 is almost equals to 37 degrees. Okay, that is a very common value. Sin cos for 37 degree and 53 degree, because they are complementary angles. Those values are very important to remember, especially if you are preparing for JEE exams or any other NEET style of exams. Okay, so this is one of the very common angles. So the answer is 37 degrees. You can leave the answer over here, you can leave the answer over here. Now the question is, the same question is asked, and if they ask you what is the tension of the wire, if they ask you tension of the wire, then what you have to do, you have to square both sides and then add it. That is t square sin square theta plus t square cos square theta equals to 60 square plus 80 square. Right? Now t square will be common, so what you will be left with, you will be left with t square into sin square plus cos square. So sin square plus cos square will be definitely 1. So from there you can calculate t square equals to, and then you can calculate t equals to. Okay, that part I am not doing, but you should remember how you can solve in case they ask you what is the tension of the wire as well. Easy step, not difficult, right? So answer is 37 degree. Next question. A driver of a car moving at a 25 meter per second sees a child on the road 70 meter ahead and stops the car 20 meter earlier to the child. If the mass of the car with the driver is 1000 kilograms, calculate the force exerted by the brakes on the car and the time taken to stop the car. So first of all, we have to calculate the force. So how can we calculate the force? The very old formula, that is father equals to ma, that formula we will use. But we do not know what is A here. Okay, how to calculate A? So the car was coming at a very high speed of 20 meter per second. He sees the child, he applies the brake, it stops. Okay, so initial distance was 70 meter, final distance is 20 meter. So what is the displacement? So displacement in this case is basically 70 minus 20, that is 50 meters. So 50 meters is the displacement of the car. Okay, obviously applying brakes means it is a retarding motion, right? So retardation means the acceleration will be negative. Now we know that S equals to ut, no, not this equation, we will not use this equation again. So as I said, the equations of one dimensional motion are applicable in laws of motion chapter as well. And here what is important is that the car is coming to a stop. That means the final speed is 0. So what formula we will use? V square equals to U square minus 2as. Why we are using this formula? Because time is not given, so we have to find a formula where time is not provided. Final velocity is 0 because the car is coming to a rest. So final velocity is 0, initial velocity is 25, and we are trying to find the acceleration, in the other terms deceleration, and the displacement is given 50. Okay, so 100A, 2 into 50 is 100, so 100A equals to 25 into 25, that is 25 square, that is 625, right? So deceleration is basically 6.25 meter per second square. This is the deceleration. Now what will be the force? So applied force is basically using this formula. So force equals to mass of the car is 1000 kilograms, deceleration is 6.25, so it will be 6250 Newton. Very, very important to understand. There is a force unit is Newton. Now calculate the force exerted by brakes on the car and the time taken to stop the car. Now you have to find the time taken to stop the car. Again we will use another equation of motion. What is that? V equals to U minus AT. The old equation for first equation. So final speed is 0, initial speed was 25, acceleration we have calculated 6.25, and we are trying to find this time t. So t is basically equals to 25 divided by 6.25. Okay, so 6.25 means 2.5 into 2.5. So what we can say, 2.5 into 2.5. How? Because 6.25, right? So what we will do, we will say 10. So 10 divided by 2.5 is 4. You can use your calculator to calculate it. I don't like to use calculator. Okay, that is why I always try to solve answers in a innovative way. Okay, if you want to success in your competitive examination, then definitely you have to stop using calculators other than your exam. That is one of my tip in your future. Don't do it right now. You have to use calculators. 6250 Newton and 4 seconds is the answer. Now again, next question. A machine gun of 15 kilograms fires 0.2 kg bullets at the rate of 10 per second with the speed of 300 meter per second. Calculate the force required to hold the gun in position. Now this question might appear very difficult, but actually in truth it is a very easy question. Okay, so what is the thing that we are going to use? We know that force is basically rate of change of momentum. So dp by dt, dp by dt or delta p by delta t, whatever you are comfortable with, right? So now in this case what is given is What is delta P? Delta P or dP? Delta P is basically mass into velocity, okay, and delta T, so m into delta V by delta T. So if we know what is the in this case velocity is constant, right? Velocity is constant, and that is 300 meter per second, but the mass is changing. Why? Because it is firing bullets, okay, and one bullet is of the mass 0.2 kg, and 10 bullets are hitting per second. So mass is changing, mass is increasing. When you are shooting to a target, basically what is happening, the mass that is getting out of the bullet is increasing. So here you have to understand that this is delta m by delta T into V. Now what is delta m? Here delta m is mass of one bullet into the number of bullets that you are throwing per second, okay, throwing. So delta m by delta T is basically this. This is the main problem. If you understand this logic, this concept, entire problem is solved. Okay, so first is, what is this mass of the gun is actually a distractor. You don't need the mass of the gun to solve this question. So mass of individual bullet is 0.02 grams, 0.02 kilograms, and how many bullets you are firing per second? You are firing 10 bullets per second. So per second is basically this delta T. Okay, per second is basically this delta T. So this is your delta M and delta B by T. And what is the velocity? Velocity is given 300 meter per second. 300 meter per second. So this is the force required. That is 2 into so you can say 2 by 100. 0.02 is 2 by 100 into 10 into 300. So 0, 0, 0, 0 cancels. 3 2s are 6. 6 into 10, that is 60 Newton. Okay, you have to show this calculation to get full marks. Okay, this calculation is very, very important to get full marks for this question. Okay, so let's see the answer, 60 Newton. Now let's move on to the last chapter, gravitation. Okay, so gravitation is our last chapter. Let's see the question. Assuming the earth to be a sphere of uniform mass density, how much would a body weigh at a depth equal to 1/4 radius of the earth if it weighs 200 Newton on the surface of the earth? What will be the weight of the same body at the center of the earth? So first of all, how does the mass weight changes with the depth? Okay, so with the depth, the mass at some depth, say D, is basically, so not mass, mass will remain same. So weight at a depth, say I'm denoting weight with WD, okay, basically is mass into gravitational acceleration at that depth, right? Mass will remain constant, gravitational acceleration only will change. Now how the gravitational acceleration changes? Gravitational acceleration is basically mass on gravitational acceleration on the ground into 1 minus d by r. This is the formula. So if we put that formula over here, what we will get? Mg into 1 minus d by r. Now mg is what? Mg is the mass, weight of that object on the ground. So Wd is equal to W into 1 minus r by 1 minus d by r. So here W is the mass, weight on the ground. Please pardon me, I am saying mass again and again, but it is actually weight. So weight on the ground times 1 minus d by r. Using this formula, whatever you have used to calculate the gravitational acceleration, same formula can be used to calculate the weight as well, right? So you don't need to use the g, value of g in this problem. So how to solve it? Here it is given that d is basically at a depth equals to 1/4 of the radius. So 1/4 r. Okay, so d is given 1/4 r. So d by r equals to 1/4, right? Cross multiplication. So we have to put that value over here. W is given 200 Newton and 1 minus 1/4. right? 1 minus 1/4, right? D by R is 1/4. So it will be 200 into 1 minus 1/4 is 3 by 4. That will be 50. That is 150 Newton. So at a depth of 1/4 of the radius of the earth, the weight will be 150 Newton. Okay, and at the center of the earth, D equals to 0, the depth, sorry, D is equal to R. At the center, D will be equals to R. That is, we can say that 1 minus D by R will be 1 minus R by R, that is equals to 0. So this multiplier will be 0. So weight of all the objects at the center of the earth is 0. Okay, so center of the earth is basically a point where the source, we consider that weight of the object is 0. Let's move on to the next question. A raindrop of mass 1 gram falling from a height 1 kilometer hits the ground at the speed of 50 meter per second. Calculate the work done by the gravitational force, work done by the unknown resistive force. Very interesting problem, but very simple problem, trust me. So when the raindrop of the mass 1 gram was at a height of 1 kilometer, okay, what was its initial gravitational potential? So the potential of that is mgh. Now when it reaches the ground, okay, it is some work is done against the force of unknown resistive force. Okay, some force, some resistive force is trying to oppose it, but gravitation will not consider anything. Gravitation will only consider that, okay, initial energy is this, so I have to do this much of work to bring it to the ground. That is my job, that is my work to do. Okay, so it will only consider how much height it is, and that much work I have to return. So the gravitational work done is basically mgh. As simple as that. The gravitational work done is basically mgh. Initially, whatever height it was, the same height will be, same work has to be done in gravitational force. So m is 1 gram. 1 gram means 1 into 10 to the power of minus 3 kilograms. Okay, you have to careful. Now g is given 10, or you can assume 10, and say g is mentioned 9.8, sorry, so you have to use 9.8 here. Okay, there is no other option. So 9.8, and height is given 1 kilometer. 1 kilometer means 1000 meters, right? 1 kilometer means 1000 meters. Now 1000 and this 10 to the power of minus 3 will cancel, so whatever you are left with is 9.8 joules. Okay, the unit of work done will be joules, so don't put the unit here. Okay, you can put the unit here or here as well, but if you put in here, then you have to put this in bracket, right? So the work done by gravity is 9.8 joules. Now what else? Work done by the unknown resistive force. Very interesting. How to calculate the unknown resistive force? So first you have to remember that the speed at the ground, just before touching the ground, the speed is given 50 meter per second. So 50 meter per second means it will have some kinetic energy still left. So it started with this much energy. Initially it started with this much energy. Whatever is the final energy, okay, the difference of that energy should be the work done against the resistive force. Okay, resistive force, the question should have been better if they have given work done against the resistive force, because work done by the resistive force anyway will be negative. Work done against the resistive force is something that we have to consider. So what is the final kinetic energy? Final kinetic energy is basically half mv square, that is half into 10 to the power of minus 3, that is 1 gram is 10 to the power of minus 3 kilograms. V is 50 into 50. Okay, so this is the 25 into 5 is 125, 0 into 10 to the power of minus 3 joules, that is 1.25 joules. So this much energy is still left with the raindrop. So remaining energy has to be spent while doing work against the resistive force. So work done against the resistive force is basically how much you have started with, how much you are left with. So you started from home, okay, and you reached somewhere, okay, so you spent some money on the way. You spent some money on the way. You started from home with say 100 rupees in your pocket. You travel, you went to the bus, you give the bus fare, you took some auto or cab, a small cab, okay, you spend some share auto person or some fare, and once you reach there, you buy some chocolate, okay, for your friend, and whatever you have left with, that is basically the remaining amount you have spent. Right, so this is the that is the amount that you have spent when it reached the ground, okay. So it is 9.8 joules and 8.55 joules, okay. So this is the answer. So not super difficult, right? The conceptually may be slightly difficult, but mathematically not super difficult. Now let's see the next question. A pump on the ground floor of a building can pump up water to fill a tank of volume 30 meter cube in 15 minutes. If the tank is 40 meter above the ground and the efficiency of the pump is 30%, how much electric power is consumed by the pump? Okay, so first of all, what is the volume of the tank is 30 meter cube. So volume of the tank is 30 meter cube. So what is the mass of the water that we are trying to lift? So mass of the water that we are trying to lift is basically volume into density of water. What is the density of water? Density of water is 1000 kilogram per meter cube. Okay, very important. Not 1 gram per cc. 1 gram per cc is in CGS unit, but in SI unit is 1000 kilogram per meter cube. Okay, so this is 30 or 3 into 10 to the power of 4 kg. This is the mass of the water that we are trying to lift. Now what is the energy required? Energy requirement is basically very simple, mgh, right? M is 3 into 10 to the power of 4, g is 10, height is 40 meters. This much joules energy we need. Now this much joules energy, how much time we are using it? We are using them in 15 minutes. So what is the power? Power is basically energy that we are spending divided by time we are taking to do it, right? So 3 into 10 to the power of 4 into 10 into 40 divided by 15 minutes. 15 minutes means 15 into 60 seconds, right? Now cancel this. 3 5s are 15. Okay, then we have 40 20, 6 2 3s are 2, right? So it will be 2 into 10 to the power of 5 divided by 15. Okay, so if you solve it, it will be 200 by 15 into 10 to the power of 3. So you have borrowed 2 zeros. You can do this division, and if you calculate it, you will get the answer to be 43.56 kilowatt. So 43.56 into 10 to the power of 3 watt, that is the unit of work done, power, or 10 to the power 3 can be written as kilo. So 43.56 kilowatt. This is the answer. You can leave the answer over here also, or you can convert it into kilowatt. That is also fine. Now let's move on to the next question. This is a model question paper, question 44, right? the base of a copper boiler is 2 centimeter thick, has a area of 0.01 meter square. The steady difference in the temperature between the phases is 5 Kelvin. Calculate the mass of the water that is evaporates in 1 hour. Given the thermal conductivity of the copper and latent heat of the steam, everything is given. So I told you to use this formula. This is the total heat that is supplied, and that heat is used to vaporize the water. So to vaporize the water, the latent heat is basically m into L. So this formula I told you to use. Now I will show you how can you use. So what is K? K is the conductivity, 385. Okay, what is the area? Area is given 0.01 meter square. What is the delta T? Delta T is 5 Kelvin. Okay, what is the distance? Distance is 2 centimeter, that is 2 into 10 to the power of minus 2 centimeter. Okay, what is the time? Time is 1 hour. 1 hour means 60 minutes. 60 minutes into 60 seconds. So everything has to be converted into seconds. Now mass we don't know. Latent heat is given 2.2 into 10 to the power of 2.2 into 10 to the power of 6. Okay, in SI unit joules per kg is given. So this is the mass. So now mass will be equals to everything that we have calculated, 385 into 0.01, okay, into 5 into 60 into 60 divided by 2 into 10 to the power of minus 2 into this one will be coming down to as division. So 2.2 into 10 to the power of 6. If you calculate everything, you will get the mass of the liquid that is getting evaporated, which will be 1.575 kg. You need a calculator to calculate this value. Okay, this is not super good question. You just need to know this formula, and you have to equate it with the ml, that is the volume of the mass of the water that is getting evaporated. They could have given the values slightly better. Now second question, also model question paper, I have given you the formula, and some students ask me, sir, please solve it. I am going to solve it again. The string 1 meter long is under tension of 440 Newton. If the fundamental frequency is 100 Hertz, find the mass per unit length of the string. What is the mass of the string? Now fundamental frequency for a string on that stretch is given by F equals to 1 by 2L square root of T by mu. Okay, if you have done the sound bridge experiment, there you have used this formula, right? Now what is F? F is 100 Hertz. Okay, so F is 100, 1 by 2, L is 1 meter. These are just put the formula, get the result kind of problems. Okay, T is 440 Newton, but the formulas they have asked is not super easy to remember. You have to find the mass per unit length, that is mu. Okay, now what you have to do, you have to square root of 440 by mu equals to, this will cross multiply, so it will go here, 2 into 100, that is 200. From there you will have to do the square on both sides, so 440 by mu equals to 200 whole square, or mu equals to 440 divided by 200 whole square. So if you calculate it, you will get 0.011. Okay, 0.11 kilograms. Okay, so this will be the mass, and this is the mass per unit length. What is the total mass? Total mass is mass per unit length into the length of the water. This is kg per meter. Okay, be careful, mass per unit length is kg per meter. Now what is the total mass? Total mass is that mass per unit length into the total length. Total length is 1 meter, so that is 0.011 kilograms, which is obviously equals to 11 gram. So you can answer it in grams, you can answer it in kilograms, both are acceptable. So this is not W, this will be kg. Okay, this will be kg. Okay, so 0.11 kg or 11 grams, whatever you are comfortable with. So we have solved all 12 very important numericals, and also you have solved 2 remaining numericals from your model question paper. So I hope you enjoyed it, and definitely I will wish you all the best for your PU1 final exam, and definitely you have to subscribe to this channel and give this video a thumbs up. I'll be back with more such videos when you go to the PU2. Till then, bye.